AB corresponds to BC. So AB here corresponds to PQ. My apologies. Yeah, that corresponds to that. If we can just, yeah. And then we have this other one, which is um, BC, the longer one. This one corresponds to QR. So that one. Um, so, I mean, you can also use highlighter if you want, just to give you an idea of what corresponds to what. So they want us to find the values of X, Y, and Z. Now, obviously, just by inspection, you can see clearly that this angle, these two angles should be equal. So X will be 63 degrees. So that should be obviously 63 degrees. So X is 63 degrees. And then moving on, what you can do, well, to find Y, which is basically that side, we can take the ratios, those corresponding sides. So basically y over 4, look at the yellow guys. So y over 4 should be equal to um, the ratio of the other sides that are unmarked, because these two correspond, the ones that are unmarked. So that should be equal to 5 over 8. Yeah. And then, which implies that y will be equal to 5 multiplied by 4 over 8. So that will be 20 divided by 8, which is 2.5. So y is 2.5. And then to find z, again, we take the ratios of the corresponding sides. So z over 6, the blue guys, should be equal to um, the unmarked sides. Take the ratio of the unmarked, just like we did here. So z over 6 should be equal to 8 over 5. 8 over 5. So basically, z will be equal to 8 multiplied by 6 over 5. And if you plug that in the calculator, that will be equal to 9.6. So that's basically how you solve that question. You can see how coloring helps just to know which one corresponds to what. Okay, number 11. So basically, the question is, are these two rectangles mathematically similar? You should show sufficient working to justify your answer. So how do we show if two shapes are similar? By checking the ratio of their corresponding lengths. So that's basically what you're going to do here. So check um, the ratio of corresponding lengths. Okay, so basically these are rectangles, which means that will be 20, that will be 10, that will be 15, that will be 25. So basically we can go ahead and, just take the ratios of corresponding lengths. So basically that corresponds to that, and that corresponds to that. So we want to check whether 25 over 15 will be equal to 20 over 10. Of course, these are not, because 20 divided by 10 is 2, and that's not the same as 25 over 15. So because the ratios of the corresponding length, and when I say corresponding length, this is what I mean. That length there corresponds to that. And this length here corresponds to that. Now, if you take those ratios, clearly you can see that you don't get the same answer. So one shape is not enlarged from the other. That's basically what it means. So they are not similar. Okay. Um, Number 12. So the diagram shows triangle ACD. B is a point on AC and E is a point on AD, so that BE is parallel to CD. AE is equals to 4 and AC is 11.7 and all these other lengths. So basically, the question is, they want us to find AB and ED. How do we go about this question? Now, one thing you have to remember is that because these two lines are parallel, that implies that this angle should be equal to that angle, and this angle here should be equal to that angle, and these two triangles, the smaller one and the bigger one, share this angle there. So what I'm going to do is I'm going to draw triangle ABE and ACD separately. This is what I mean. So here I'll have triangle, the smaller one, and here I'll have the bigger one. So the smaller one is B, that's BEA, and here we have, well, I'll draw the angles later on, and then here I have CDA. You can see that both of them share angle A, which is marked here. This angle here, angle C, is equal to angle B, and angle E is equal to angle D. All right, now we have two similar triangles. We can plug in the measurements. So basically, here we have 6, here we have 13.5. The entire length AC is 11.7, and then AB is, well, that's unknown. AE is 4, so this is 4. So basically, we can solve AB by taking the ratios of this length. So basically, let's start with AB, so part A. So AB, which is this one here, this corresponds to that. So AB over AC, which is 11.7, should be equal to BE, which is 6, over CD, which is 13.5. So that implies that AB will be equal to 6 multiplied by 11.7 divided by 13.5. And if you plug that in the calculator, that will be equal to 5.2. All right, part B, they want ED. ED is this one. Now we'll have to work out this question in 2 steps. Step 1, we can start by finding AD, and then once you find AD, we can subtract that from 4 to find ED. So step 1, let's start by finding AD. Now to find AD, we just go back to our 2 triangles here. So AD over AE, which is 4, should be equal to CD, which is 13.5, over BE, which is 6. So AD will be equal to 4 multiplied by 13.5 divided by 6. And if you plug that in the calculator, that will be equal to 9. And now step 2, we can proceed and find ED. Now we know that ED is equal to AD minus AE. Now AD is 9, AE is given here 4, and 9 minus 4 is 5. So ED is equal to 5.